Actuary has done an analysis of all policies that cover two cars. 70% of the policies are of type A for both cars, and 30% of policies are of type B for both cars. The number of claims on different cars across all policies are independent. Distributions of the number of claims on a car are given below. 4 policies are selected. Find the probability that exactly one of the 4 policies has the same number of claims on both the covered cars. So the main idea is a policy having same number of claims means either the policy will have 0 claims on both cars, 1 claim on both cars, 2 claims on both cars, or 3 claims on both cars. So let's see what happens if type A policy has same number of claims. So type A policy will have same number of claims on both cars if it has 0 claims on both cars, which means 0.4 on the first times 0.4 on the second, because 40% is the chance of one car having 0 claim, and for both cars having 0 claims, we multiply the two 40%. And similarly, for both cars having 1 claims under type A, we'll multiply the two 30%, and so on. So let PA be the probability that the selected policy is A, the policy which has same number of claims on both cars. Then P of A would be, as we discussed, both cars could have 0 claims, so that's 40% times 40%, or means addition. Both cars could have 1 claim, that was 30%, 2 claims was 20%, and 3 claims was 10%. So both 30%, or both 20%, or both 10% if both have 3 claims. So that total probability is 0.3. Similarly for B, it's 0.25 times 0.25, because for B all the probabilities of any number of claims is 25%. So both cars having 0 claims in type B would be 25% times 25%, or both having 1 claim will also be 25% times 25%. So you could have 25% times 25%, and you have that 0 claim or 1 claim or 2 claims or 3 claims, so you add them. Or you could just do 25% times 25% and then multiply that by 4, and so it's 0.25. And the probability that the randomly selected policy has equal claims on both cars is the probability that policy A has been selected and equal claims, or policy B could have been selected and equal claims, right? Because there are only 2 types of policies, policy A and B. So selecting policy A is 0.7 probability, because 70% are type A and 30% are type B. So selecting policy A, 70% and equal claims, we've determined above for A, the equal claim probability is 0.3, so 70% times 0.3. Or you could have selected policy B and have equal claims, so policy B is 30%, and equal claims in policy B is 0.25, this one. And so this is 0.285. That's the probability that the randomly selected policy has same number of claims on both cars. So our question was that among 4 policies that are randomly selected, what's the probability that calculate the probability that exactly one of the 4 policies has equal number of claims on both cars. So it's a binomial situation with n equals 4. The probability of one policy having equal number of claims is 0.285. So that's a little p. then we have to find the probability that exactly one of the four has equal claims. So x is equal to 1. So this is the binomial formula, NCX, 4CX, little p power x, and 1 minus p power n minus x. So we want probability x equals to 1, that's f of 1, and substitute x equals to 1 here, you get 0.417, and that is choice D.